Okay, so the next one is another limit where we have to calculate only from one side. Now, interestingly, the professor has asked you to simplify the expression and then find the limit. Now, this is probably just so that you can get the practice, get to recognize the formulas and so on. I'll show you that solution too. But in this case, actually, if we start with direct substitution, as I typically advise you to do, then we would have minus 2 squared minus 2 minus 2 wow, so many minus 2's, over 8 minus 2 cubed. And now if we keep going, we get minus 2 squared, which is just 4. Minus gives us plus 2, and then minus 2, over 8 minus, and now whenever we have minus 2 cubed, because the exponent is it is odd, then it's a minus, so minus 8. And this gives us, these cancel out, this gives us 4 over 8 plus 8, because we have minus minus. 8 plus 8, which is 16, or in other words, that's 1 over 4 if we simplify. So, as you can see in this particular problem, you actually get to just like find the correct answer through direct substitution, right? But in order to satisfy the requirement from the sample, let's go over it and try to firstly simplify and then substitute, right? So we have limit as x approaches minus 2 from the right of, okay, I'll just copy it for now, but I won't spend time manually rewriting it. I'm just gonna copy that thing. And from here, what do we do? So firstly, at the top, we see that we have a quadratic equation, right? So how do we factor out the quadratic equation? As I told you, we need to find two numbers that when multiplied give us minus 2, and when summed give us a minus 1 in this case, right? We don't really write the 1 in the coefficient, but in this case it's a 1. So let's start here. We need two numbers that when multiplied give us minus 2. So that could be minus 2 and 1, or 2 and minus 1. And I guess that's pretty much it. I can't think of any other combinations of integers that give us minus 2. And now out of these pairs, we need to find the one that when summed gives us this thing. So if we take a look at this one, minus 2 plus 1 is minus 1, which is exactly what we needed, right? Therefore, that's our pair of values that we're going to plug into the factors formula. So it's going to be, let me just move this a little bit to the side. So it's going to be x, oops, I want my white back. So it's going to be x, and now I plug in this value, so x minus 2 come on, bro, I cannot write today. And then we're going to have x, and now I bring in this value plus 1, okay? That's our factored form. Now, at the bottom, this is a formula. This is 2 cubed minus x cubed. And here, I don't really have an explanation. You just need to remember the formula. So this is going to be 2 minus x in the first parentheses. And then you have 2 squared. That's just how the formula goes, right? 2 squared, which is going to be 4, plus the multiplication of these two, so 2x, plus that thing squared, x squared, okay? And now that's kind of tricky. By the way, here I forgot to write the limit, but I need it. Okay, so now keep going. Limit as x approaches minus 2 from the right. So now this is interesting because here we almost have the same 4. We could almost cancel it out, with the only difference that here the signs are flipped, right? Here we have plus x minus 2, plus x minus 2. At the bottom we have plus 2 minus x. So what can we do? Well, we can actually put a minus in front of either of these. It doesn't really matter which one it is. In math, we typically prefer to have something in the form of x minus 2, so maybe I would just keep the top the same for consistency. And at the bottom, I'm just going to take out a minus in front, because now the thing in the parentheses can become x minus 2, right? Because if you take this and you distribute back, just to check that you're right, you're going to get minus x plus 2, which is 2 minus x, which is exactly what you had above. So we're not changing the expression in any way. Like, we're not changing the value, we're just remodifying it so that we can now cancel out. But once again, you could have taken out the minus in the numerator, and that's just as right. Okay, it doesn't matter. And then in the denominator, I don't even need the brackets anymore, but I'm just going to keep them for readability's sake. So it's going to be just 4 plus 2x plus x squared. Now, before I try like factoring out the denominator or anything, I'm going to plug in minus 2 because maybe it'll work out now. So I can do, if I plug in minus 2, I'm going to have minus 2 plus 1 in the numerator over 4 plus 2 times minus 2 plus minus 2 squared in the denominator, which is minus 1 in the numerator, over 4 minus 4 plus 4. Oh, wait, okay. I was about to like go crazy because it was about to be a minus 1/4 and I was surprised, but I forgot something. We had this minus here, right? Yeah, that's a very typical exam mistake, by the way. I also do it on exams. I did it now, but you should try to be careful. I don't know. Maybe when you're on your exam and you have such a sign that stands out, maybe actually circle it so you don't forget. But I need to have this sign in front of the whole thing. So now it's going to be minus that thing. So that's minus 1 over minus 4, which gives me 1/4. And that's exactly identical to the first result I got. So on the exam, in case the professor asks you to, simplify and then find the result, you need to go through that longer version. But I don't remember ever having that in my exam. So if you're just given the limit, you'd better just go for the direct substitution, get the result, and move on, right?